happen to have been able to see the installation ceremony for Professor Kirk when he was installed at the Century Insurance in Bachelor. Cool. How many of you saw it on YouTube? I think you might need to work on your clicks just a little bit. One of the things that I stole from that is the knowledge realm of data analytics that we're talking about here. So we can see that when we look at data analytics, we look at some of the different variables between computer programming, mathematics and statistics, and the business expertise. So we've heard a lot from some of our presenters so far about computer programming and mathematics and statistics. I'm here to talk more about the business expertise side. How do we go about taking that information and translating it into information that our managers use? So there's certainly quite a bit of computer programming and math and stats that went behind it, but that's not going to be my focus here today. Okay. Generally, I'm going to give you just a quick introduction to some of the theories that we use when we do consumer research. I'm going to look at a few of the different techniques that we have for assessing variable importance. Keith Strand talked about a few of those just in the topic beforehand. I'll go back old school for a couple, and then we'll also bring in a couple more modern ones. And I'll use a case study of actual data to take us through that today. And then finally, at the end, but it's kind of the important part, is trying to figure out how do we convey that information of all these runs and the logs odds ratio and random forest and decision trees and correlation and multiple regression. How do we communicate that to the managers so that they can use it for information when they're making their decisions? So, why are we talking about attribute importance? Why exactly is it, well, important? I will tell you that in the 10, 15 years that I've been working in the market research service industry, the number one question that I get from 95% of my clients is what attributes are really important to me. I've got $2 million to introduce this new product. How do I know where I'm supposed to spend that $2 million? What's important to my customers when they go to make actual purchase decision in any sort of industry? So, Kurt, I'm going to toss this to you just for a second. One of the other things you mentioned in your ceremony was some work you did on attribute importance with a hotel chain, right? Can you share with everyone what happened in that particular finding for you?
Well, we kind of had a pre-specified belief that 50% of the importance had to do with I think it was 75% of the importance had to do with non-service issues, and then only 25% had to do with service issues. And so obviously they were spending a lot of money with regards to renovations and stuff like that. And when we got done doing a very large study, we found out that it was about 50-50. So they started reallocating funds to make sure that the customer service experience as delivered by their employees was much better than it was. And it had a major impact on the chain. Grew tremendously in the past few years, and so that was kind of shocking to them because they had these pre-held beliefs as to what was important, but nobody knew how they came up with those beliefs. So.
They used their business expertise, but in that case, the data analytics and the mathematics and statistics weren't really supporting that decision, so they had to kind of change things. So how do we go about assessing attitudes and importance? Because these questions are so vital to the current manager, we kind of rely on a couple of main theories. Going back to the 1940s, and I mean butcher these names, but Patrick Crutchfield talked about attitudes inside a customer's mind as this enduring construct that could be linked to judgments on the outside world. Myers and Albert said, well, that's kind of interesting, but what does that have to do with managerial decisions? How do we know which ones are important? And he said it's rather important to make sure that the features that we're looking at are the ones that are actually closely related to whatever decision the customer makes. Okay? And then finally we have Fishbein's multi-attribute attitude towards an object model. How many of you studied that before in some of your classes? Just a couple of students here coming out of social psychology. But basically, this is the about the biggest math I'll come up with today. It says that a person's attitude towards a brand or a product can be described as the sum of the importance a person places on the attribute times the performance of that attribute. So what are attributes exactly? Well, if we think about phones, I think several of you here have a phone. What are some of the important attributes that you think about when you purchase a new phone? Anyone?
Battery life.
Battery life, exactly. I've had to charge mine 3 times already today.
Network.
Say that again?
Network.
The network. Are you getting drop calls or not? Okay. How about screen size? Form factor. Camera. Anyone who has small children, the camera is particularly important to teenagers alike. So the fishbone model says we can simply multiply the importance that each person attaches to that attribute and multiply it by the performance, sum it over all the attributes, and we get their attitude. So for performance, we have a pretty good way of determining how to do that, right? We just ask them, how do you think the iPhone 11 performs on network connectivity? How is their new camera? Okay. But how do we go about getting importance? I'm sure at this point you're saying, just ask them, right? Ask the customers. What's important to you? Battery life, right? What's important to you? Network connectivity. The problem is that when we ask them, first of all, the model falls apart. And the reason why the model falls apart, it doesn't tend to predict attitudes all that well, is because when you ask customers to rate these attributes, what are they going to say? Oh, you know what? Yeah, I really want this really cool camera because the pictures are really important to me. And oh, I don't want to carry a really heavy phone around in my backpack or in my purse because it's too much. Oh, well, you know, that form factor, I like to have the latest and greatest. And pretty soon, everything is, well, important, right? So where does that leave the manager? Pretty much the same place where they started. So instead of using that stated importance, we tend to go back to something called derived importance. And derived importance, instead of asking, leverages analytical techniques in order to assess that importance directly. So some of these we've talked about today, right? You heard some people talk about random forest. I know we have a couple people in our audience who are well-versed in conjoint and discrete choice and math diff. Those experimental techniques work really well when you have time and effort and dedication to set up that experiment and have a study that's focused just on those things. Unfortunately, in my world, when I deal with customer satisfaction and loyalty, most of my clients don't have the money or the interest in doing such a narrowly focused thing. Instead, we tend to have surveys that ask about everything under the sun, right? And so the way that we can look at that observational type of data can be either simplistic or advanced kind of techniques. So simplistic techniques are ones that have been around for quite some time, right? We can look at our standard correlations, the betas. The advanced techniques tend to utilize the magic of running multiple regression runs or multiple analytical runs instead of just the one. So let's go ahead and talk about one of our main issues when dealing with survey data instead of experimental data. So who was it who asked the question about correlations and collinearity? You. So I think he answered it already, but this is kind of a visual representation of what we're talking about. If we have a survey where we said, okay, how satisfied are you with the service that the phone rep gave to you overall? And we have attributes that are friendly and knowledgeable, and those two attributes are not correlated. They don't cover each other very well. Well, then importance is pretty easy to understand, right? We look at how much of the variance of our outcome variable can be explained by each of the attributes. If an attribute explains more of the variance, well then that's more important, right? So in this case, we would find that knowledgeable tends to be more important. Okay. Want to guess what % of the time in customer satisfaction survey data this actually happens? How many would say it's over 20%? How many would say it's over 50%? In my data, never. You because we're designing surveys that we think explain an overall run. And we have managers that we work with that think it's really important to talk about things like, oh, our customer reps, well, we want to know how much knowledge they have, or we want to know how helpful they are. And really, those two things are probably a lot more correlated than anything. Okay? So we tend to use the more advanced techniques, especially when we have issues with linearity. Okay. So my case study, and I really changed quite a bit of the true information about this in order to protect my client confidentiality. But the industry, we could think of it as a service quality industry. Basically, members of a subscription service own a piece of equipment that is really prone to breaking down. So, something like a phone, something like a computer, something like an elevator, something like a printer in an office, something like that. And if you subscribe to this service, you can simply call and arrange to have a technician come out and visit you on site. Okay? And the expert technician actually travels to the customer and does the setup and problem solves. So we sent out surveys. We got about 854 of them back over a couple of ways. And we measured, first of all, the overall satisfaction with the service event, a couple different phone rep attributes, how easy it is to reach, the representative's ability to help on the first call, and the follow-up call that the representative made after the service event. The technician, we had a few more attributes there, how long it took them to arrive. They gave kind of a promised window of what time they were going to arrive in, so satisfaction with that. Willingness of the technician to help, their ability to resolve the situation, and the professionalism of the technician. All of these are measured on a 0 to 10 scale, where 0 is not satisfied at all, and 10 is more highly satisfied. So let's start by looking at our standard measure of how much influence and relationship each of these individual attributes might have with our dependent variable. If we look at just the square Pearson's correlations, I don't have here all variables were positively and significantly related to our outcome measure. What do we see is popping up as some of the higher correlations on a bivariate basis? Well, the representative helping on the first call, the representative following up, the tech amount of time it took them to arrive, and the ability for them to arrive within the promised time. So if we were just looking at these individual correlations, we would say those four are what we call key drivers. How many here heard the term key driver before? Pretty common, right? Variable importance key drivers, pretty similar. We would say those four are key drivers. The ease of reaching, somewhere in the middle. I might call it a secondary key driver, depending on how important it might be to the client. Interestingly enough, the technician's willingness to help, ability to resolve, and professionalism were way down on the list. Okay? So we would not say that those were driving satisfaction with the ultimate service event. But what we need to do is kind of go beyond these bivariates and see, do we have our problem with collinearity among our variables? Well, you look at this. Remember, we want the correlations with the outcome in the first column to be super high. Ideally, we like these to be 0. These are the real-life correlations we see on survey after survey after survey. They're much higher than 0, right? In fact, we have the technician amount of time to arrive, and arriving within the promised time is 0.88, higher than any of the individuals with the outcome variable itself. Really, we think probably those are measuring the same thing, right? Believe me, I tried to get the client to drop one of these because I think they're the exact same thing. But they make a big deal about this promised time and following up to make sure it is. So they wanted to have it in the survey. We also see some of these lower ones, the technician willing to help, ability to resolve, and professionalism, very much highly correlated with each other too. So those are causing problems with that. We don't know when it's correlated like that, how much should we assign to one and how much should we assign to the other? We don't know what percent of mean variance they're explaining. So let's see what happens if we do a multiple regression model. So when we do this multiple regression model, I ended up removing a couple of these correlated attributes so that we were able to get some solid numbers with regards to our collinearity measures, the variance inflation factor. We want those to all be under 10. They're pretty good, right? We've got 1-3 scores, so well within the threshold that we want. The condition index also is sort of a measure of collinearity in our model. Typically, we want those to be under 30. We've got one going up to about 15, but they all meet the measure. You doing okay with that? So how do we decide which one of these tends to explain our outcome measure more? We have a different way of looking at it, and that's to look at our betas. So if we look at our betas, either on standardized, since they're on the same scale, you can use standardized if they're on different scales or different measures. Here we find it's the amount of time it took them to arrive, the representative's ability to help on the first call, and the follow-up call kind of goes down quite a bit. Okay. Interestingly enough, the technician's ability to resolve, that beta is only 0.1. So if you move up a whole point on their satisfaction with their ability to actually resolve your problem, it doesn't really translate to an increase in their satisfaction overall. Any idea why that might happen? How many of you have heard the word table stakes? Table stakes are attributes where pretty much everybody expects this to happen. So the classic example is airline safety, right? We pretty much expect when we step on an airline, we're going to arrive at our destination safely. There really isn't very much variation between most of the major carriers in terms of how safe they are. When that happens, it's not going to turn up as very important in your model usually, but it will if somehow you drop below those accepted performance levels, right? All of a sudden you start seeing a few crashes, God forbid, but with a couple of different crashes with the same airline, and that's going to become really important really fast, right? Okay. Our multiple R squared is pretty good. Some things to think about when we're trying to translate this to management, if we were to try to use this to explain which variables are important, is we have an intercept term here that doesn't make a lot of sense. And we know that as analytical people that we can kind of just ignore that. But some of our clients don't really like that. We say, well, your model is saying it's negative 0.308, but that's not even on our scale. Our scale is 0 to 10. Right? So that can be a little challenging. Sometimes you have to standardize the data if you're not on the same scale. And data requirements make things a little bit more complicated. We're on the same scale, so I didn't have to deal with standardization or logistic regression, so it made things a little easier. Okay. Combinatorial types of importance, and I think Keith, you mentioned that was a new term to you, something that you hadn't used before in management, but you thought that might be helpful to explain to management. Can I call on you to tell me why you think that word combinatorial might be better than crust goals or Shapley's or something like that? Any idea? Why could we call this combinatorial when we look at crust goals type of analysis? It combines the regression runs over a number of different runs. It's not just relying on one run. And so it helps to address the issues sometimes that we have with collinearity. It parses out the contribution that each variable has. And it averages the effect of the R square. And we get some output here. This is summed to 100. Again, we're seeing the tech willing, the ability, the professionalism still coming up on the bottom, right? Our middle ones, the first call, the representative follow-up, and the time to arrive are really the stars in this particular model. promise and the ability to reach the representative with ease are kind of our secondary drivers in this model. So we can see things start to change from our more simplistic models, right? Our bottom three are the same, but the top ones are kind of changing a little bit too. One of the challenges that we have with the combinatorial effects or techniques like Huskel's or Shapley's, and they're really pretty similar. I think one uses semi-partial correlations, one uses partial correlations. I can never remember which one. Typically, a market research firm is just going to use the one that they tend to use most often. I'll give you one hint as to which one Market Pro uses most often. It's Huskel's. But it quickly can become pretty computationally extensive if you have a lot of different variables. So if you're throwing in everything from the kitchen sink in the survey, and usually we're asking at least 100 different attributes in every different survey and trying to regress it against overall satisfaction, that becomes a pretty intense thing. Certainly modern computational power makes that easier, but that is something to consider. The other thing is that the numbers change depending upon how many attributes you have in the model. Okay, so unlike bivariate correlation, this number for, say, the tech time to arrive is saying that it's putting about 16% relative to everyone else. If we cut this down to try to eliminate our correlated attributes, tech time to arrive jumps up to 28%. So that number is different, and the position can change depending on how many numbers you have. In our random forest approach, and this was a new one that was suggested to me when research firm a few years ago by someone else in our audience, and that was Joe Retzer. And you were told me that you had a number of successes using that to use variable importance to your clients. Is that right?
Yes, I think the variable importance is very intuitive to explore. It's one of the things I can explain to a client. It's a little bit. So that was the big one.
And then if you add on things like shiny, which I know you've done in the past, I haven't done here, you can do a lot of manipulation. You say, okay, if we move the score up for this one attribute, how can we contribute it to others? So it handles collinearity fairly well. Also handles missing data very well. I haven't talked about that, but Huskel's is rather problematic with that. I won't go over the advantages or the single truth. I think Keith really talked about that pretty well. But here's the results of the mean decrease in the Gini for the model that has all of our attributes. So I'm looking at kind of where the breaks are, right? We have the numbers over there. And we see the ability for the representative to take care of things on the first call is coming out number one in this model. Right? Our similar secondary attributes are right in the middle, and professionalism, ability, and willingness are coming down as being not so important. Here's just a little bit of the R code that I had fun playing around with on that using the random forest package. Our out-of-box estimate of the error rate was 29.74%. So not too bad. Not the greatest, but not too bad. So decision time. Guess what? None of that stuff I just showed you is what my client wants to see. Their eyes are going to be glazing over even more than yours are right now, and they're not trying to get to lunch, but they are trying to get to their next meeting that Joe talked about earlier this morning. That's scheduled in 2 minutes. Even putting it all together in a table like this, their eyes are going to glaze over, right? So we need to choose one. The one thing that I point out is kind of, evaluate your data for some of the different possibilities of the collinearity, missiness, your data types, consistency across the techniques. Your bottom ones, I think you can rule out as being important at this point in time for your customers when they're evaluating their satisfaction with the phone. Another interesting to point out is correlation and your regression has very different changes in what the most important item is. But our more advanced techniques like Huskel's or random forest agree. The numbers are different, but they agree. Okay? So somehow what we we want to do to convey this to managers so that they can make useful information decisions is tell the story of the importance. Maybe put the top one in a dark color, the secondary ones in a medium color, and the light ones in the light color to kind of show you. Sometimes we put a little symbol by it, by the key. Another thing that we do at Market Grove is put in something called a quad chart. What did you call it at Paris?
Performance improvement plan.
Performance improvement, yeah, much more useful. We also call it a performance importance chart. And that brings in, remember our fishbone model, right? We have importance, but where was performance when we were looking at either of these? We don't really know how the company was performing on it. In this type of chart, we put performance on the bottom, higher is to the right, lower is to the left, meaning the satisfaction scores, or you can do means. And the importance is on the vertical or y-axis. Higher importance is on top, lower importance is on the bottom. And it connects it to the actions that the manager should take, right? In the top right, we have two things that they do pretty well on. They're moderate importance, protect arriving time and within promised time. So you want to protect that, right? You just kind of want to make sure it doesn't go below the levels you expect. But where you really need to focus your efforts are what's in the focus group, the representative's first call and the follow-up. And I have to tell you, this was very controversial. They still don't believe it. They don't like it. They're using an offshore call center, so that's a big part of it. They're trying to arrange technicians that are located in the U.S. They have no idea that someone in Palm Springs, Florida really isn't that far away from Palm Springs in California. So they're running into lots of problems there. And so even though they wanted to put money into their technician, we convinced them you really need to deal with your representative before you can focus on that. Okay. Got 1 minute for questions. Or we got to get lunch, go ahead.
On the bar chart, what would promote the bottom right one?
Sure. So these are areas where you're doing quite well, but they don't seem to be that important to your customers. So it could be something that you could mention to your customers as, hey, we have the #1 ratings in this area, but realize it's not going to have a huge impact on some of the things. One of the other things you can do with this squad chart, I didn't have time to cover today, but instead of just pure performance, you can put relative performance according to your competition. So things on the right might be, well, you're far above where everybody else in the market is doing, and those are things you really would want to promote. And then the ones on the left would be, it might be a high score in your survey, but you may not be doing much better than the competition. So that can change the location there, depending on what perspective they want to look at. Well, thank you for this more business-focused time today. I appreciate it, and enjoy your lunch, and we'll see you throughout the rest of the day.